What's up, guys? So welcome to the GRE subject GR 993 674. Sometimes it's hard to pronounce this type of the English alphabet. Okay. So 64. 64 is also old school question, but I will. Old question. Let V be a real vector space of real value functions defined real have a derivative of all orders. Basically, this is say that V is called C infinity function. So basically, C infinity means that you consider a function from real to real, and Fn exists for all n. So basically, it's just the infinite differentiable function. This is a real vector space because you add two infinite differentiable function which is still infinite differentiable. And if you times any constant, then it's still infinite differentiable. So V is a vector space. And he defined a map called T from V to V. They define a map called D, V to V, just from F to F prime. And ask about eigenvectors. So now everybody knows about setting. This is stupid that we just try to solve the eigenvector, right? So what's the definition of eigenvector? It's a df should be lambda f for some lambda. Up to now it's unknown. So just like when you solve the matrix, the lambda in the beginning is unknown. So basically df is f prime. So we just solve f prime equals to lambda f. And everybody knows the answer, right? This is an exponential function. So this is df of a df over dx equals lambda f. And then with df lambda dx, and do integration, you have log f equals to lambda x plus some constant. And this tells you that f is exponential lambda x times some constant. So this is the eigenfunction. Eigenfunctions, or people call it eigenvectors. Usually in matrix algebra, in linear algebra, we call it eigenvectors, but in functional analysis, we call it eigenfunction. But basically, they are the same. So eigenvector of D, no, the answer is C, right? Because eigenvector, right, just exponential something. We already proved it. So the answer is C. The answer is C. Yeah, so simple, right?